Hello, welcome to Flipped. So today we'll be analyzing paper chromatography, and there are three ways to use the results for paper chromatography. First one is to compare known and unknown samples. So for example, if I have an unknown sample X here, okay, and I run the paper chromatography along with known sample A and B, okay, A and B separates into their individual components, right? So A separates into A gives rise to this yellow dot, B will run to this position here with this pink dot. And at the same time, X breaks up into two portions, one in yellow, one in pink. And you can see that they are in line with A and B individually. Okay, so we can determine that, okay, unknown X contains A and B, okay, because the dots separate into exactly the same line as A and B. Okay, and that's how we know X contains A and B. Okay, the second way to analyze a paper chromatography result is by determining its RF value. Okay, RF value, the formula is given here. Okay, it's distance of the substance, okay, traveled divided by the distance traveled by the solvent. Okay, so let's take a look at for this using this example here. Okay, when we say distance traveled by the substance, we mean from the pencil line all the way to the dot position. Okay, so this is the pencil line, right? We draw a line with a pencil, then we drip the dot here, and after some time it will run to this position, for example. And this, okay, this length is the position for the new dot, and we call this the distance of the substance. On the other hand, okay, when we let this paper chromatography experiment run, okay, the solvent will also go up towards the top. Okay, and this is called the solvent front. So the solvent front doesn't have any dot or any colors to indicate that it's the solvent front, but you will be able to know it because this area will be wet, whereas this area will be dry. Okay, so the wet area will be the solvent front, the final line. Okay, because the solvent actually wets the paper chromatography paper, and so it'll be wet. Okay, and at a point between the wet and the dry area will be the solvent front. Okay, and so to determine the distance traveled by the solvent, you just have to take the length between the paper line and the solvent front. For example, 4 cm here. Okay, then you just plug in the values, okay, to find the RF value. In this case, the RF value for this dot in particular, for example dot X, okay, it's 3 cm divided by 4 cm, okay, and that will give you 0.75. And there's no units here because the units cancel out each other here. Okay, and that's all for RF value. Next and final method to use the result for paper chromatography is using locating agents. Okay, so in the previous two examples, we have shown you paper chromatography with colored substance, right? What if I tell you my substance is invisible, okay, and I let it run in the paper chromatography experiment? It breaks up into two dots. Okay, I know they break up into two dots, but I don't know which or where they are. Alright, so this is an example of this. Okay, I let the experiment run. There's nothing to see. But after I spray it, okay, I spray something called a locating agent. I can accurately see where the dots are. Okay, how this happens is that the locating agent actually binds to the substance here. Okay, and the binding actually causes it to have color. Okay, so now my molecule, okay, has colors for me to identify. Okay, for example, this becomes green and this becomes pink. Okay, and from here I can do, for example, RF calculation and etc. Okay, and hence this is called a locating agent. So in your syllabus, you don't have to name any locating agents. Okay, but this is one example, is ninhydrin. Okay, but this is the overall idea for locating agent. And with that, these are the three ways you can use your results from your paper chromatography to do analysis.